Till now what we have seen, the FM demodulation using FM AM conversion method or frequency discrimination method, and there we discussed that we need a frequency selective network whose frequency response satisfies this property that we have seen in the last lecture. And we have seen that one such frequency selective network is an ideal differentiator with frequency response as J2 pi f. So it can be used as a FM demodulator. So this is what we have studied, that theoretically differentiator and ideal differentiator can be used, but how to practically realize any ideal differentiator? So an ideal differentiator is difficult to realize, but we can approximately realize a differentiator with slope detection. So here we study the practical. Now till now we have seen the theoretically that an ideal differentiator can be used as a FM demodulator for FM to AF conversion, for the FM to AM conversion method, for the FM demodulation. So here any differentiate, we will approximate differentiator with a device whose, or with any linear system whose frequency response contains a linear segment of positive slope. So what I am trying to say here, that the any differentiator has such a characteristic, such an impulse response, since Jf is J2 pi f, mod of Hf is 2 pi f. So maybe a device is not linear for the whole range of the frequency, but may have a linear segment. If we plot the frequency response of a linear device whose frequency response is like this, if you remember, this is nothing but a high pass filter. So if you see its frequency responses might not be linear in the whole range of frequencies, but it is linear for a segment. So it has a linear segment, it contains a linear segment. That is what we are saying here, that any linear system whose frequency response contains a linear segment of positive slope can be approximated as an ideal differentiator for this range of frequencies. So if you set your frequency, carrier frequency here in such, and the linear segment is such that the bandwidth of the FM modulator here, this point is Fc plus Bw by 2, this point is Fc minus T by 2. So it actually has all the FM band, right? So if any device have a linear segment over FM band, we can approximate it as a differentiator and we can use it for the FM demodulation. So there are two such devices which can be used, linear device. Yeah, so this method is known as slope detection. Okay, so just remember this. So we are now approximating an ideal differentiator with slope detectors, which and slope detectors are nothing but any linear systems whose frequency response contains a linear segment of positive slope. One such device is high pass filter, whose frequency response you remember from your network course or signal system course is this. So if it can be approximated as a differentiator if this property is satisfied. So if your f is, so this is the range of f. I mean, for this, if you can satisfy this property, then you just remember this. If you satisfy this property, we can approximate as a differentiator. Similarly, an RLC circuit, if you remember, RLC circuit is a resonant circuit whose resonant frequency is this. Right? It will also have a linear segment here. So we can use this device also as for the FM modulation, FM demodulation, and we can set the carrier frequency here at center of the linear segment, and we can set our, and if these 2 points are such that they are Fc plus Bw by 2 and they are Fc minus W by 2, It means the linear segment is long enough that it contains the whole FM band, which are FM waveform having the band. This linear segment is having that band. If the linear system contains that FM band, then we can use this device as for the FM demodulation. So next we will discuss the other methods of FM demodulation.